So 2.3 Fatigue and Recovery by Maxwell. So just a little introduction to fatigue. Fatigue is a reduction in force production and or power and the inability to produce the force required. In simple terms, fatigue is the feeling of being tired and exhausted. This can be caused by many things such as not sleeping enough, poor diet, and exercising, which is what we're going to be focusing on in this video. Within exercise, different activities can cause different types of fatigue. Local fatigue is caused by repeated contraction of the muscles, which is felt in those muscles that were contracting. General fatigue is felt perhaps after a training session or a game. It's the feeling of your energy stores being depleted and you just feel tired and like you need to eat. And then chronic fatigue is when an athlete is constantly training and doesn't get a long enough rest period, so they're training day after day after day, and they just feel absolutely exhausted with all their training sessions, and all their energy stores just feel drained. So for example, a person in a gym doing a heavy squat is most likely to feel local fatigue in the leg muscles from the repeated contractions, whereas a basketball player who is training every day and not getting enough rest between their exercise is much more likely to feel chronic fatigue. So this demonstrates that different activities can present different types of fatigue. So during a maximal intensity but short duration activity, we use the ATP-PC system as it is readily available in the muscles. PC stands for phosphocreatine. It provides energy for a short duration. However, this suits the maximal intensity as it's only a short duration. So phosphocreatine only lasts for 10 seconds in total, meaning that after this time, PC stores will need to recover first before it can be used again, which is roughly around 120 seconds before they're recovered. The almost fully depleted PC stores contribute largely to the decrease in power in maximal exercise. Also, reduced ATP turnover happens during maximal intensity, which causes a large reduce in power. These decreases in power affects performance as it limits how long a person can work at maximal intensity. So as shown in this graph, when muscle PC levels drop, ATP levels will also decrease and cause a person to become tired, fatigued, and exhausted, as it says here, which will fatigue a player. So for example, a person doing a bench lift at a high weight will do a certain amount of reps and then start to feel a muscle soreness and can't physically push up the bar for the last rep. This is this is because their muscle PC levels have been depleted after 10 seconds and they don't have enough power because of the power decrease, that they can't push up. This is why many weightlifters have spotters for the last few reps to help them safely get the bar over the rack. Also, a 100-meter sprinter, they'll feel an immediate local fatigue in their muscles after the event due to their PC levels dropping after about 10 seconds as they are depleted. So how can this sort of fatigue be reduced in maximal intensity? So creatine supplements, shown here, can be taken to delay the effects of fatigue and maximal intensity. Creatine supplements increase the PC stores in your muscles before exercise, as shown in the graph here. So we see that when the person takes PC, the creatine supplement, their levels are much higher. This allows a performer to work at maximal intensity for a longer duration as they have a longer supply of creatine. This creatine powders, instead of powder, it can be added to drinks like milk or water for high intensity exercise. So yeah, these are just the examples I talked about earlier with the fatigue in the bench lifter and the sprinter. So what about moderate intensity during a moderate duration? So moderate intensity and moderate duration exercises often use the anaerobic system. 200-meter and 400-meter races are both examples of this type of activity, and will both use the glycolysis system for energy. RER, which is the respiratory exchange ratio, can be used to determine what energy fuel is being used during this type of exercise. When glucose is the main fuel that's used, glycolysis happens. This is when glycogen is broken down into pyruvic acid, which is then converted to lactic acid when oxygen is not present. Lactic acid builds up as a waste product, which produces H+ ions as it is an acid, which increases the acidity in the muscles and therefore lowering the pH in the muscles. This prevents the enzymes that break down glycogen from working. It inhibits them. So this decreases the power of the system and stops it from working, as the glycogen can't be broken down anymore. So this therefore prevents the continuation of the exercise as the muscles become fatigued. The point at which the lactic acid builds up and affects the enzymes is known as OBLA. A fitter athlete will be able to delay OBLA to happen much later on, so they can work aerobically. This is shown in the graph here. So OBLA is where lactic acid starts to build up, and then it increases much further, which is where it starts to affect the enzymes. So to combat the buildup of lactic acid, alkaline solutions can be used as a buffer to neutralize the lactic acids. Athletes do this by soda loading, which involves drinking sodium bicarbonate before an event. This absorbs the lactate, and the hydrogen carbonate ions combine with the H+ ions to form carbonic acid. This can help delay the buildup of lactic acid during performance. This graph here shows the effect of soda loading. So it decreases here, it's decreasing the percentage pH, making it less acidic. So it's better for the athletes. However, it does have some side effects. It can cause vomiting and diarrhea. Another way is glucose ingestion, which keeps the levels of glucose high in the muscles, meaning that fatigue can be delayed as carbohydrate stores take longer to become depleted. Glucose can be ingested during exercise in the shape of gels and also sports drinks. This graph here shows that after drinking a sports drink, the athlete ran the race in a shorter time than with just water. As mentioned before, 200-meter and 400-meter and also 800-meter races are all examples of this type of activity, and would both use all of them would use the glycolysis system for energy. The 800-meter and 400-meter races are too long for the PC system to be used the whole time, so glycolysis is used. By the end of the race, lactic acid would have built up in the muscles and lowered the pH, causing fatigue in the legs of the athletes, as the enzymes breaking down glycogen are not fully effective, as we said before. There would be a larger buildup of lactic acid in an 800 meters runner's legs than a 400-meter runner, purely because they're running further and it's longer for the glycolysis system to be working. So submaximal exercise requires a small intensity with a high duration. Therefore, the aerobic system is used, as the low intensity allows the body to work with oxygen. So instead of being turned into lactic acid, pyruvate goes through the prep steps in aerobic respiration. Aerobic respiration mainly uses glycogen stores to function, and if these stores run out, then we slow down and fatigue. This can happen during these long duration events and is commonly known as hitting the wall in a marathon run. When a performer's glycogen stores are completely depleted, they cannot continue and end up hitting the wall. Fats and proteins can also be used as energy types, as shown in this graph here. The fats often contain more potential energy, so they, in this sort of sub-maximal exercise, can be used. So RER would suggest that 60% fat and 40% carbs are used in this type of exercise. During long activities involving exercise, we lose water as a waste product. The water content in the blood plasma decreases, which decreases the viscosity of the blood, making it thicker and harder for the heart to pump it around. This is known as dehydration and is a factor in fatigue. The heart must pump harder and faster to pump the blood around, which therefore increases heart rate. Carbon dioxide is also produced as a waste product during long duration exercise. The majority of carbon dioxide is turned into carbonic acid as a way to transport it in the blood. This is around 70%. Carbonic acid, as it's an acid, also lowers the pH of the blood, which can decrease the effectiveness of enzymes and can cause fatigue. So there are also, this one's there are also neuromuscular fatigue. So the neuromuscular system is vulnerable to fatigue in this sort of exercise. Muscles can be fatigued by still having the stimulation from the neuron, but there's no contraction. This is potentially caused by three factors. Firstly, because the energy system has run out of ATP and can no longer be resynthesized. Therefore, the impulses are still sent, but silent filament theory cannot work without ATP, so therefore there is no contraction. Another way is the buildup of lactic acid. This inhibits the enzymes that break down glycogen, which prevents muscle contraction even with stimulation. So the buildup of lactic acid in this sort of exercise would come from when we are no longer working aerobically, when our glycogen stores have run low. We'll start using the glycolysis system and lactic acid will build up. The last way is the loss of sodium or potassium ions. These ions are needed to repolarize the nerve in order for the impulse to move along it. The loss in ions prevents repolarization so that the impulse does not reach the neuromuscular junction and therefore contraction does not happen. There are also other causes of fatigue in the muscular system. One is acetylcholine depletion at the synapse, which is shown in this diagram here. A depletion at ACH means that the impulse cannot be restarted at the muscle filament across the junction, so contraction can't happen. Another way is cholinesterase depletion. This is the enzyme that breaks down ACH to be used again. Loss of this enzyme comes from the inability to start a new impulse at the muscle. Without this enzyme, ACH can't be used again, and therefore the impulse has no way to cross the synapse. Lastly, there is calcium ion depletion. Calcium ions free the active binding site inside sliding filament theory at the muscles during exercise. Calcium depletion causes tropomyosin to still block the binding site, shown here. So therefore, sliding filament theory can't happen, causing athletes' performance to drop in their muscles because they can't contract. So how can we reduce fatigue in this type of exercise? So making sure that we are hydrated throughout the event so that less water is wasted. Also drinking isotonic drinks mixed with water can help keep glycogen levels high while also maintaining hydration, which this keeps the athlete powerful for longer. Pre-cooling involves cooling the body before exercise. This lowers the rise of body temperature so that in the middle of the exercise the body temp is not as high and only a small amount of blood is being redirected to the skin to get rid of